Welcome to part two of glaciers and cold climates. Landforms, we'll start with icebergs. Now, when a glacier enters a body of water, whether it's the ocean or a lake, since ice floats, the buoyancy and the ice floating on the water may cause the ice to break off into the water. It's not supported from below anymore, and so that may allow it to break off. Now, since ice floats, most of the ice is actually below the surface. So whenever you see an iceberg, you're only seeing just the top eighth of an iceberg. This other remaining 7/8 is below the water. So it's just the tip of the iceberg that you're seeing. And so here we've got a calving event where some of the ice breaks off from the snout of the glacier. I mentioned it in part one, but that chasing ice video is the most amazing calving video I've ever seen in my life for icebergs breaking off. Now, these are small icebergs. This is near the Serrano Glacier in South America in Chile. We got all excited to see some students who are roughly 20, 25 years old run ahead of us on our little hike to the glacier. I'm thinking, oh, they're really excited to see the glacier. No, they were really excited to get their beer in the water to chill it while they were there watching, observing the glacier. And I thought, oh, I got to do that next time. So next time I go to a glacier, I'm bringing beer with me to stick in the water because basically it's got giant floating ice cubes in it. And so the water's nice and cold, and then be a great place to chill your beer. I'm not sure about the Chileans' choice of beers with Corona, but we'll let that one go for now. So another glacier, you can't see it, it's back here in the fog, unfortunately, but these are bergs that have floated off away from the glacier into the lake. This blue color, again, is spectacular. It's a beautiful blue, but it's from light refraction. The glacial ice, the berg, is not blue. So in Iceland, we had this massive ice field feeding into a pond, and the pond is just a few meters above sea level, so it feeds into the sea very, very quickly. And so this area would have been maybe reunited with the sea as sea level rises, but right now the big bergs that break off from the ice field behind it just kind of float around in this water, waiting to slowly melt, and then pieces will break off and go out into the ocean. Here's the ice field in the background, and we will talk about this feature later. This is a medial moraine. I just think icebergs are beautiful. So what we're seeing in Antarctica, some large sheets breaking off from the surrounding ice. So the ice comes off the continent. It stays a couple thousand feet thick, and it goes, some of it floats and goes out over the ocean floor. Some of it still rides on the ocean floor. But with the warming temperatures, we're starting to see some of those big blocks break off. Another piece, this is 2001, but just this last year, another big chunk of Pine Island broke off. I mean, the scale on these things, 30 kilometers across, 150 kilometers, almost 100 miles long, this glacier 2 years ago, or this berg 2 years ago breaking off. And when you see something and you're seeing that, 250 feet of ice, well, that's the top eighth. There's another, this thing is probably 2,000 feet thick of ice. And for scale, always use Statue of Liberty for scale. Now, if glaciers are really good at eroding, it would make sense that the glacial, once it's eroded and transported that material, you're going to see deposition of that material. And so we'll focus on glacially deposited material and then some of the other weird little things that glaciers can form as well. So I'll start with till. Till is anything glacially deposited. Kind of like alluvium is anything that's stream deposited. Till is glacier deposited. Now, since glaciers, there's no sorting, it's frozen into it. So there's no function of discharge that allows it to move bigger pieces versus smaller pieces. So you've got large boulders mixed in with gravel, sand, clay, everything together. So when the glacial ice melts, the till that's deposited just kind of settles in place. So it's unsorted. So glacial till is unsorted material. Around the edges of glaciers are what are called moraines. And so since the edge of the glacier, especially a valley glacier, is going to do so much erosion, it would make sense that there's a lot more material in the side of the glacier that got caught into it. And so a moraine is still till, it's just till that's deposited at the edge of a glacier. I will go over all three of these things again. And then erratics are the random things that fall on top of a glacier and they get carried by the glacier. So this is glacial till, unsorted. Notice there's no rounding like what you get from water transported material. So the moraines at the side, again, this is unsorted material, but the moraines are, as the glacial ice scours along the side of this wall, it's going to pick up a lot of sediment. And then as the ice continues to flow forward, it will deposit that ice from the side of the glacier along the side down and through here. The glacier itself is transporting material in the interior, so as it melts, it leaves behind material at the snout of the glacier. So the stuff that's at the snout or the end of the glacier, that's referred to as an end moraine. There's different types of end moraines. I'll show them to you later, but we're just going to use the term end moraine for anything that is at where the snout of the glacier is. And then lateral, these are the lateral sides of the glacier. Those are lateral moraines. I'm not showing it to you now, but any guesses as to what a glacial created moraine in the middle of a glacier is? That's right, it'll be a medial moraine. So lateral on the side, end at the end, and medial in the middle. So this is the end moraine, where it reached an equilibrium point for a period of time. The glacial ice is retreating. It may have reached another equilibrium point for a short period of time. That's a type of end moraine. And so the subcategories of end moraines I'm not going to worry about. A terminal moraine is its farthest extent. A recessional moraine is where it would be for a short period of time. I worked at a wildlife refuge that was built on a recessional moraine. And then the lateral moraines are on the side. So what happened in Yosemite Valley is the terminal moraine was not breached, like from the meltwater. And so since the terminal moraine remained in place, it created a lake behind it. And that's why Lake Yosemite was formed, because the terminal moraine, the end moraine, was not breached. So unfortunately, with some of the limitations of animation available to me right now, that you just have to visualize this glacial ice moving, and then anything that it's carrying ends up building up at the snout of the glacier. So where the glacier was, well, after it melts, it's referred to as a till plain. Till plain and outwash plain will not be on the test. Till plain is the material that kind of builds up underneath the glacier and kind of melts in place. But if you're on the other side of that moraine, there's going to be meltwater flowing across here. But the meltwater can only move fine-grained material, sand and clay. So there's places in the northern portions of the United States where literally you can be a half a mile away and have a construction site on one side that's all sand and clay, and then a construction site a half a mile away that's all rocky and gravelly, just simply because one was glaciated and the other one was just the outwash plain. So here's a crude pencil animation of a continental glacier expanding and retracting, creating end moraines as it expands and contracts over time. So the initial expansion creates an end moraine, and then one of the recessional moraines. Notice your braided stream right here. Just a reminder about stream processes. And there you go. Here's an end moraine that's been washed out. It's been breached from the meltwaters. So back to Serrano Glacier. So the beers that the guys had in the water was right over here. This is the moraine. That's sea level. That little speck of blue right there is sea level. So we're only about 6 to 10 feet above sea level where this lake is. And the end moraine for the glacier, for where it was for an extended period of time, was here. It's since retreated, and the end moraine has been breached. And so here you can see it's unsorted. You can kind of see that the glacial ice would have been piled on top of it right here. And then the kind of the grayish color, that's the glacial flour mixed in with it. Now the medial moraines, they occur where two lateral moraines come together. So as this ice is flowing down the valley, this ice is flowing down the valley. This has the lateral moraine material building up. This one has the lateral moraine material building up. Well, then they come together. And now that lateral moraine becomes a medial moraine, and it just works its way down the valley as the glacial ice moved. So anytime you see this stripe, you should be able to go up valley and find where two valleys come together. So this one, you go up valley, you find where, hey, two valleys come together. This one, and then the one over here. Now this one doesn't get it because this is so small. It really just kind of gets mixed into the main glacier as it moves through. There's a medial moraine where this glacier comes together with this glacier. And so if you go up here, there's got one coming here and one coming here. And then this medial moraine coming here and coming here. So picture what would happen if this ice melted. In the middle of the valley would be a ridge of unsorted material. In the middle of this valley will be a ridge of unsorted material because it'll just kind of fall and drop in place as the ice melts. So what you're seeing here, the ice is obviously gone, but here's a lateral moraine, and then the end moraine's kind of been washed out. Lateral moraine, and then the end moraine from all the meltwater kind of washed it out. Hey, look, it's an alluvial fan. Ice sheets do similar. Lateral moraines aren't common just simply because you're not going along the side of the valley. It's not to say there isn't some local condition, but usually you're dealing with end moraines, either terminal or recessional moraines in the area. So Long Island is part of a terminal moraine. Parts of Massachusetts, terminal moraine. Where I worked on the wildlife refuges, a recessional moraine was in central Massachusetts. These are just fun, couple of fun glacial features that I think are kind of weird. Now, as a continental glacier moves across sediments, some of the till underneath the glacier may get kind of squished together. It's a function of varying ice pressure as it weighs down on the surface, and it creates these odd little streamlined hills, and they're called drumlins, and they tend to occur in a group. It's not unusual to have groupings of them, and they're called drumlin fields. I just think they're weird and funky, but not quite as cool as eskers. I love eskers. So in the summertime, when you've got a glacier ice in an area, some of that meltwater is going to accumulate underneath the ice. And it doesn't flow in a sheet flow underneath the ice. It kind of gets squished together and concentrated in one area. Well, it's going to behave just like a stream does. So sometimes it's in the subsurface, sometimes it's on the surface of the glacier. But if you've got flowing water, it's going to transport sand and clay and fine grained material. Well, when the ice melts, that sediment that was being transported by the stream is left behind. And so you may have a ridge going down a valley, but it's not going to be a medial moraine, because a medial moraine would have rocks and larger boulders in it, whereas an esker is sorted, it's fine grain and sand material, and they tend to be kind of discontinuous and sinuous because as the glacial ice moves, it may disrupt ancient eskers. And so this one here, that sinuous nature of it, that's indicative of an esker. And I just think it's cool that at one time this would have been covered in ice and this would have been a stream flowing underneath the ice. And so this is where a stream outlet would be. And of course, they had to use a red circle in case you couldn't see it. Now, this particular stream channel has been transporting boulders as well. So this would have been till that's kind of mixed in with it, and you couldn't pay me to go into one of these. I love these eskers in Iceland. Sinuous in nature. You can see some of the sorting in through here. There's the fine grain material that would have been transported that season. Smaller gravel and sand-sized particles, no giant boulders mixed in with this. I have no idea what he's doing at that moment. Canada, they're kind of discontinuous. So you've got one that snakes through here and another one that goes through here. Again, fine grained material. And they're sometimes they go sideways. A medial moraine would be in the middle, or linear, paralleling the valley floor. Erratics are funky. So this is stuff that either got frozen into the ice or commonly too fell on top of the ice. And so you've got a boulder that's not native to the area where it's found. So this is a big chunk of granite sitting on top of sedimentary rock. Well, this granite just doesn't magically appear on top of sedimentary rock. It got carried here during the last ice age. This is older limestone on top of younger sandstone and shale. Well, remember, the oldest stuff is supposed to be on the bottom. Well, this big chunk of limestone has been transported dozens of miles from another source, frozen into the ice melts, and it left behind the erratics. So to give you an idea, it's just simply erratics can be from the mass wasting that occurs because you've got really steep slopes, and this is just rocks that fall on top of the glacier. And for scale, you get an idea that the glacial ice can carry massive boulders on top of it. It doesn't care. and it just carries them away. And so imagine if this ice all melts, you're going to find this boulder kind of settling in place, but it didn't come from here. It came from up valley somewhere. So these rocks here are erratics. They're from that side of the canyon over there. The glacial ice flow moved them to this present location. Now, kettles are typically either in the outwash plain as the glacier is melting, or if the glacier kind of melts in place because they're no longer being fed new ice. And all the sediment, the sand, the fine grained material will kind of build up around these blocks of ice. Ice doesn't melt uniformly, and so you get some areas that maybe the ice is a little dense, it's not as cracked as much, and so it lasts a little bit longer. And so once they finally melt, they'll leave depressions. The wildlife refuge I worked at in Massachusetts had a kettle on the moraine because the big chunk of ice had frozen into the moraine. And then when it finally melted, it left a big depression in it. And they were actually going to use it as a trash pit. And I, no, don't. This is, we created a little nature walk around the visitor center. And that was one of the features, was the kettle that was formed. There is actually a famous kettle, Walden Pond. It's that book by Henry David Thoreau about a gentleman's journey into reflection and existentialism. It should be required reading. At some point in your life, you may be trying to figure out who you are, and that would be a good reading for you. But it's about the quiet reflectiveness. But Walden Pond would have been a big block of ice that melted in place and left behind the depression, and so that's what the water filled, creating a pond. They're really noticeable in the northern Siberian plain because it's a relatively flat area. So when the ice stopped flowing into the area, gravity wasn't carrying it anywhere. It just kind of melted in place. And so these are all kettles you can see in here. And there's a clue that this is a low gradient environment. Anybody see it? Yep. It's the meandering stream. And then another meandering stream in through here, that it's a low gradient environment. So our last cold climate processes, this would be stuff that's not directly related to glaciation. We're only going to focus on one, and that's just simply permafrost. We could be dealing with periglacial lakes, lakes that were formed during the last ice age. Lake Bonneville in Utah, for example, is a periglacial lake. But I just want to focus on permafrost. And permafrost would be soil or rock that stays frozen year over year. Obviously, under a glacier, the glacial ice is frozen, the soil underneath it isn't going to be warmer, it's going to be frozen as well. So these would be high altitude or high latitude locations where the top surface of the soil may thaw out, but beneath it, it remains frozen. That's permafrost, permanently frozen permafrost. As you'd expect, it's the high latitudes where it's prevalent. And so unfortunately with permafrost, when that top layer melts, it tends to get kind of marshy and boggy, then it refreezes. And when water freezes, it expands. And so this kind of odd, just what you're seeing here are pressure ridges from when the soil expands, when it freezes and it pushes against itself. Because the subsurface is frozen in the springtime when the ice melts, you'll get kind of these marshy, boggy conditions. And so this is picture, when I downloaded it, was a road in Siberia, was what it was titled. And I had a Siberian student laugh. As soon as I showed the photo, she started laughing because she's like, yep, she calls it the roadless season because in the spring after the melt, you can't go anywhere. Ice Road Truckers, that amazing television show where they transport everything in Canada and Alaska during the wintertime, they do that because when everything's frozen and has a layer of snow and ice on top of it, you can't damage anything. It's really difficult to transport material through permafrost in the wintertime, in the summertime, because it's kind of soft and boggy. Or you get weird things like right here. This is an ice lens. And so water collected in a layer and it froze together and then it melts a little bit and more water accumulates in this area in the wintertime and it's pushing apart layers of the soil. And of course, construction, if you're melting and thawing at uneven rates based on sun exposure, how thick material is. And so notice how undulating this road is. A lot of times in an area that have permafrost, they just simply use gravel roads because maintaining roads in this area is a nightmare. And buildings, you're going to want to heat the buildings. So these are in Siberia. And so the Soviet system was that one big heater feed a whole building. And so the big heater in the center of the building caused this permafrost to melt more underneath it. And so the center of the building sagged. And you can see how this building kind of has an undulating shape to it because the differential thawing of the subsurface. These buildings in the Yukon, permafrost again, where maybe there's something about sun exposure where you're seeing more melting on this side versus this side, creating a kind of sagging underneath it. Usually at these high latitudes where there's permafrost, the only reason you have any civilization is for mining activities or crazy people. You just don't simply decide you want to live in Siberia. The Alaska pipeline, this goes through permafrost in Alaska. So how do you have a pipeline that transports oil able to be underground, and if it shifts and changes with the permafrost and thaws at different rates, so the areas that have permafrost, they go above ground. And so what they have is this construction technique where these pylons go deep into the permafrost. And so even though the top layer may thaw, it stays deep enough where it stays frozen. This was over-engineered, and so even with climate change, these pylons are deep enough that they're not really at risk. And for those of you who are familiar with metals, heat transfer from one metal type to another varies. So by using different types of metal, you can minimize the effects of how metals expand and contract because they'll do it at different rates. And so you're looking at 1, 2, 3, 4 different types of metals because of the characteristics of metals as they freeze and thaw. These are heat dissipators. They're cooling this off so it doesn't get warm. The pipe itself is insulated because of the friction of the oil moving through it. Now, there is one problem with this, is that one of our sources of oil is exposed and easily compromised. There was a drunk Alaskan a few years ago who saw a giant silver moose and shot the Alaska pipeline and shut it down for a couple of weeks. All right, so to finish this off, you can put away your notes, although there might be a quiz question on this, about going to see a glacier in Norway. And so, of course, it starts in Oslo, then we take the train, change trains to get to the glacier. And typical Western European train lines, they run on time. And when they say they're going to leave at 10 o'clock, they leave at 10 o'clock. And as you leave Oslo, remember this is a CFB climate, you've got nice tree coverage, but you only need to go a few miles inland to get into the boreal forest and then to the tree line. And so it's a function of being close to the water level in Oslo that moderates the temperatures. Now we're up into the tundra, no trees in through here. We just happen to time it perfectly in that tiny window between when the snow melts and the plants begin to grow. So literally within days, this will have a kind of a coating of green on it from all the plants that are germinating after the snow melted. You go a little bit farther inland, the snow hasn't melted, and in the surrounding hills, this may never melt. Finse, it's the highest train station in Norway, and when we were there, it was summer. It was the only day above 60 for the entire year, and even at that, it was 70 degrees Fahrenheit. Norwegians are funny because the two things they like to talk about, three if you count potatoes, but they like to talk about who's related to who and the weather. And so I always have a weather story to tell my Norwegian friends and family. The day I was in Finse, it was 20 degrees Fahrenheit, and they're always amazed and think that's just an awesome story because everybody's been there at one point, and usually it's just horrific weather conditions. And I'm like, oh no, I was there. It was nice and warm. Now there's farms in this area, but it's also the people back behind it. They're going trekking through some of the ice fields, and I can't pronounce it glacier is in the background on this ridgeline through here. And if we zoom in closer to the I can't pronounce it glacier, you'll see somebody's farm buildings here. They're just waiting for the snow to melt. So we had to change trains. The one that we were on was headed to Bergen. So this was a side one. It has to be a narrow gauge rail because we're going to go down a really windy path. So we started up out here, and it's literally making 360-degree turns inside the mountain. It's totally awesome. Norwegians are amazing tunnel builders. How else do you get down to the vertical face of a fjord without going through the inside of the mountain? And there was some nice views along the way. It was a pretty train ride. So those people were going to get on a boat to go to Bergen. We were going to get on a boat to go to the glacier. So we stayed in this pensionhus over here. But I'd mentioned the Ruche Moutonnet. This is it right here. And so this is our window looking down the fjord. So this is our window down the fjord. So behind us is this Ruche Moutonnet. So the glacier would have come from this direction, gone up and over it, and then down through the fjord. You can see this nice steep face here. This is a gentle face on the other side of it. So now we switched to a ferry, and it was freezing. It was a heck of a lot warmer up on top of the mountain than it was down at sea level. Passed by some old farmhouses. Jostadalbreen, we're getting closer. It's our destination. So we went to the ice museum, because yes, that's what I do when I'm on vacation, to get the Boyabreen. And this is it here. And this is what I expected to see. And this is what I got to see. Thank you, climate change. Yeah, it's retreated up. So now that the edge of it is just what's left of this ice fall. So the glacier, the main glacier is up here. And as it flows through here, it kind of breaks apart. It's like a frozen avalanche as it's coming all the way down here. So we've gone to all this work to get here. As we walk up to the glacier, there's a sign that says no entry, dangerous conditions. I'm like, what the hell? I came this far. We're going to go up to it. So that's looking almost straight up at the ice fall above my head. Change the angle a little bit, and while I'm taking this picture, I hear this boom, boom. And what had happened was a section over here had fallen off and onto the snow. And like, oh, that's why the sign said, don't go past this line, because you could die from ice falling on your head. Me trying to look cool underneath the glacier. I think it's working. Big chunk of glacial ice. Like an idiot, I kicked it. It's really dense. That's my wife standing in front of the glacial flower fed into this lake beneath the pond beneath the glacier. And then we finally ended up back in Bergen, the land of the midnight sun. So this was right around the June solstice. We're far enough south where the sun actually does dip below the horizon at midnight. And we were there right about on solstice. But it's just barely below the horizon. And for you history buffs, this is the largest remaining Hanseatic League city or buildings in Europe. Now, why I'm in Norway all the time is I have family there. And so this is me working on the family farm. Hey, that doesn't work. All right, you guys, I hope you enjoyed your glacier vacation. And I look forward to seeing how well everybody does on the quiz and the final exam. Good luck to everybody. Thank you for the journey this semester.